Welcome, everyone, to another episode of Heat Treat Radio. I'm your host, Doug Glenn. I'm the publisher of Heat Treat Today, and want to welcome you to another episode where we talk about all things thermal process and heat treat related, as long as it's 800 degrees F or 425 degrees C and up. Basically, that's our market, and that's what we're going to be talking about, things in that range today. Want to welcome our guest today. It's Mark Rhoa Jr. out of Elizabeth, Pennsylvania, which is near Pittsburgh. And Mark's been involved with the industry for quite a while, actually, part of Chiz Brothers. And Mark, you can tell me if this is right. I mean, I think was it your dad that started it? Your dad, his brother, or what? I don't know the history that well.
Yeah. So my dad actually joined the company in '97, but when
Okay.
he joined, Chiz Bros had been around for probably a good 40 years or so, maybe 97. Sorry, I'm not a math major here, but let's say 30 years. And so, yeah, it was started by the Chiz Brothers originally, Al, Ray, and there was actually John Chiz as well. So my dad joined in '97, and then as the Chiz brothers got older, and some of them moved on from the company, retirement and all that, my dad took over the company in 2014, and that's when I came on board, and I've been here about 10 years. My dad's been there, coming up on 27 years, 30 years. So yeah, and then actually Ray Chiz Jr. is just recently, the last couple of weeks, retired. So one of the original owner's sons, who was working here running our warehouse, and yeah, so he just retired. So he's the last is with the Chiz name working here. You know, uh, we say the Chiz haircut is kind of what I got going on right here. But by the haircut, there's a lot of Chizes still working here. You might even be an honorary
Yeah,
Chiz.
I can be an honorary for sure. Absolutely. I don't have enough on the side, but anyhow. Yeah, so you guys have been around. Chiz been around for 50 some years, as you mentioned, basically doing specialty solutions for refractory applications in the metals, power, glass, ceramics industry. You guys deal with multinational companies as well as the small ma and pa shop furnace manufacturers or heat treaters or thermal processors. So
Yeah,
pretty good mix. You've got great from what your website says, great customer service and also, reasonable pricing and quick delivery. And I know you and I have talked about that you guys kind of pride yourself in having a lot of stuff in stock in warehouses and whatnot. And then finally, you guys have not just your Pittsburgh location, which is not actually Pittsburgh, but it's near Pittsburgh. You also are in Detroit, which is a relatively new addition, right?
Yeah. About 2 years ago, we opened up a Detroit warehouse. We'd always had some good customers up that way, but I really got to have to be super effective. You got to have some boots on the ground. I say to get the easy orders, you got to have stuff on the ground to get the hard orders, which, phone calls at 5 o'clock on a Friday. Hey, we need to pick this up because the furnace is down, sort of thing. And we didn't have that before opening that. So it gave us another location there for, like you said, the customer service aspect of it. We try to, punch above our weight, like, you know, compete with the big guys on pricing, make sure we're always still answering the phone,
Right. Makes a
taking,
huge difference.
uh,
Makes
yeah,
makes a huge difference when you actually got people answering the phone. Well, you guys provide, I mean, I believe, you correct me if I'm wrong, my understanding, you can provide castables, you can provide fibers, brick, whatever. Uh,
yep,
but I think today we wanna hone in a little bit on ceramic fiber. So
yeah. And ceramic fiber is the big portion of our business, or one of, if not the, depending on the year, biggest Unifrax, Alphagen, ceramic fiber distributors in the country. So yeah, a lot of what we do is being driven by ceramic fiber products we supply. Like I said, still can supply castables, bricks, everything kind of in between, but really drives the ship for
yeah.
us.
So let's talk about that, and let's assume that the people that are listening, I mean, a lot of them, we have most of our listeners are folks with their own in-house heat treat,
Yeah.
manufacture their own in-house treat. A lot of them will know some of the answers to these questions, but let's just assume we've got some people watching that don't know some basics. So tell us about ceramic fiber. What is it? How's it made? What are we using it for? That type of stuff.
Yeah. So the way I always kind of describe it to people that may not know much about it, the Pink Panther insulation that most people may recognize up there in their roofs or somewhere in their walls, right? It looks like that, a little bit different. It's white, but think about that insulation for 2,300 degrees Fahrenheit, right? That's that's what ceramic fiber is in its form that we sell at the mill shop. Right now, you can take that and cut gaskets out of it. You can take it and form it into hard boards and through a vacuum forming process. You can take it, fold it into what we call ceramic fiber modules, which and we're watching with the furnace likely probably has modules in it. If they're a traditional gas fired or electric furnace, ceramic fiber products typically aren't used on the vacuum side of things. People with all vacuum furnaces, they're probably not going to be using ceramic fiber, right? But yeah, so there's a bunch of other different ways. There's cloths that are ceramic fiber based as well, right? So ceramic fiber is made. It's a blown glass, blown spun glass. So essentially, what you're doing is dropping the liquid aluminosilicate mixture, and bam, it's getting blown super high temperatures, blown and spun. And I mentioned that I'm not going to details of the differences there, but it deals with the tensile strength of blanket, whether it's the stream is blown or it hits wheels that spin. But in the grand scheme of things, what you're doing then is you're collecting all that fiber, you're getting it onto a mechanism that's kind of moving along a conveyor belt, right? Then it's getting needled from each side to interlock the fibers, make that, we'll call it 24-inch wide right now blanket that's going to be, will be a little bit bigger because you got to trim off the excess, but let's say 26-inch wide for argument's sake, trimming an inch off when it goes through, and then bam, you got a 24-inch, 2-foot wide, 1-inch, 8-pound density roll coming out. Those densities can vary, and that really just is how much fiber is going into that, the pounds per cubic foot. But when you're using a 1-inch piece, obviously it's that divided by 12, right? From a weight standpoint. Yeah, depending on the fiber you're packing in there, needling in there, if you will. That's how it determines the density there. And there's a little bit different chemistries for 2,300 degree, 2,600 degree. And the most expensive would be 3,000 degree polycrystalline. So, and that process to make that's a little bit different too. But I think most people on this call are probably more interested in kind of what we're doing with it, right? It's kind of what's the Chris Farley line in Omnivore, we'll keep it PG, but a butcher's word for it, right? And if people know, they know where it's going there. But yeah, take our word for it. It's made the right way, right? We'll get into how it's actually used here.
Yeah, gotcha. So it's basically it's like an insulation in your house, like you said. That's probably the best description of it for people that need to know. But it can obviously go to much higher temperature. So in an industrial setting, why would you use fiber versus like a castable or a board or a brick? Let's say a castable or brick.
Yeah. So there's ceramic fiber is a great insulator, super good insulator. And, we'll probably get into a little bit later on a lot of decarbonization efforts and things like that on why better insulator is important. But yeah, certainly a better insulator than castables. And, very easy to install, very easy to use. But yeah, main reason being its insulating value and ability to have varying temperature ranges, which you can certainly do with castables and brick as well. But bricking a wall 12 inches thick, right? You can, for argument's sake, put 4 layers of 3-inch brick on there. Well, you can come in there and take one 12 by 12 module, shoot it onto the shell, attach it, be good to go from there. So yeah, really the main thing would be longevity and stuff like that, thermal shock value. So one of the things you have to work out with castables and brick, maybe not as much IFB, but standard brick is, the heat cycling. And, heat treat furnaces are a great example of that. That door is opening up a lot, backside of things. So you're getting the air coming in there. People probably see it in their furnaces, the castable's going to want to crack because it's not designed for thermal shock like ceramic fiber is. Certainly applications that you wouldn't want to use ceramic fiber, right? If you're looking at a traditional heat treat, depending on how the load is supported in there, the floor is actually, the refractor is actually supporting the load. You're going to want some sort of brick, some sort of a castable pier. Fiber is going to be soft. It's going to compress. It's going to get beat up. it's going to get really beat up. Yeah, it's not, you can't necessarily put it everywhere, but the areas where it may be up for debate on, yeah, you can use a brick in the wall or you can use fiber in the wall. Traditionally, you're going to use fiber for the insulated value, thermal shock value, and installation. And weight too, yeah, a lot lighter. So, a lot of heat treating furnaces are, you know, small relative to the massive furnaces you may see in steel melting, right? But they're going to, you're shipping them. I mean, we're talking about a 12 by 12 fiber module, 12 inches thick, weighing roughly 12, 13, 14 pounds. I mean, you're going to put brick or castable in there, you're looking at, 5 to 10 times that weight.
Right,
So,
exactly. And how about Mark? How about addressing the repairability issues between castable and brick and fiber?
yeah, yeah, yeah. So fiber, we can, especially if you're getting in higher temperatures, right? And fiber can have some shrinkage to it, but yeah, you're able to repair fiber a lot easier. If you wreck a little bit of fiber, you can get in there and get it repaired quickly. Where if a brick or cast, where everything's tied together as one, either monolithic piece or a bunch of bricks interconnected, starts to become maybe a little house of cards sort of scenario where you pull, one goes down, everything goes down. So you
Yeah,
got
yeah, right.
to
It's a
layers there. So yeah,
It's a Jenga game. You
Jenga, yeah,
pull that brick out on the bottom, and what happens?
yeah, yeah, yeah. You don't want to pull the wrong brick. Don't want
Yeah,
to pull the
yeah.
wrong.
The
Yeah, yeah,
Yeah, no, that's good. That's good. You already mentioned kind of the temperature ranges we're talking about. I think the standard, let's just say standard bottom temperature is 2300. The fibers are good up to 2300, and then you've got 2600 and then 3000. Is that roughly the breakdown of where you're looking at fibers?
yeah. And I don't know why they ended up doing this, but 2,300 degree ceramic fiber. Realistically, you only want to use it to 2,150, and that goes along with the shrinkage curve of it, right? And so I forget the exact rule. I think it's like 24 hours. So you get less than 3% shrinkage. They determine that number with. But yeah, typically the rule of thumb is you don't want to use it. You want to give yourself 150, sometimes more just to be safe, but 150 degrees of cushion there because it is determined it will still have shrinkage up to that temperature. So yeah, I don't know why whoever thought of probably some genius marketing guy to get a little extra degree. It's a typical rule of
Well,
thumb for
sometimes
that.
they say it's rated at 2300, but at typical
Yes.
operating temperature is maybe 2150 or whatever, something along that line. You mentioned it a couple different times. Address shrinkage.
Yeah.
Why does it happen with with ceramic fiber, and how does that impact installation or whatever?
Yeah. So yeah, when fiber hits its operating temperatures, it shrinks up. Great question on the chemistry. The chemistry side of that is I don't have an answer there, but why you factor that in is, ceramic fiber modules, different things will be compressed, right? So we factor in compression to help alleviate when something shrinks, it's already pushing out against something, right? So it still keeps its, what's the word I'm looking for? No air gaps, and it wants to pop back out, right? You press it down. Resiliency is the word I'm looking for, right? So, and that's something that's factored into any design, right? If you're doing 12-inch modules, you'll have a what we call a batten strip in between them that makes up for some of the shrinkage that may come that way where there's not compression. So, that's something that, any sort of design we would do, or really probably anyone would do, right? They're going to factor that stuff in and make sure that's important. Because yeah, you're right. You don't want to just put something in there that when it shrinks, leave a gap. You want to make sure you have something in there that's going to fill that gap. And that typically for modules. Now, if you get to low temperature, now I think you mentioned, heat here we're talking 800 degrees and up, right? So if you're in a furnace with 1,200 degrees, you're not going to have to worry about shrink, right? It is even in some of those furnaces, you'll see designs where we call wallpaper, where you just have a pins exposed, right? And you're layering it on top of it. So that, you're just you're still overlapping gaps, but you're not going to have any shrinkage there. So you don't really have to worry.
Yeah. One question I did want to ask you when we were talking about the different temperature ranges is, and again, not knowing the chemistry, I wasn't really interested in the chemistry. I was just curious what wanted people to know about the shrinkage. But the is the 2300, 2600, 3000. Are the chemistries between those different? I mean, you don't need to know so
Yeah, yeah, no, for sure. I mean, they're all aluminosilicate based, right? So yeah, 2300s, 50% aluminum, 40% silica, something like that. The they'll typically inject some zirconia in it, maybe around 15% zirconia. That gives it the extra boost. Aluminum is what drops down. So there is, again, we don't want to get in every exact example, but it does have a lower alumina content. So like sometimes in aluminum melting, you can get some fluxing because of the zirconia in there. So you got to know the exact application, right? Can't just get you every time. But then the polycrystalline, what people call 3000 degree, would be 72% alumina. And that's made in a calcining process and everything. So it becomes the 72% alumina is the key factor there. Now you can also have super high alumina blankets. Safil's kind of the typical brand name, we'll call that. And that's a 95% plus alumina. That's, high hydrogen app stuff where there's bad off gassing. The alumina is usually more into that. And, some aerospace applications have that stuff spec'd in for effectiveness, and also because it probably has government money. So why not pay for the highest, most expensive thing?
yeah, exactly. That's right. Got the money, pay for it. I want to thank Chiz Brothers for sponsoring this episode and take just a moment just to talk about their company. They are a family-owned company. About 90% of the stuff that they provide is all U.S. based, made in the USA. And they've got offices, their original offices near the Pittsburgh area, Pittsburgh, Pennsylvania, and they also have an office up in the Detroit area. Focus is on, very simply, ceramic fiber products, including blanket modules, paperboard, and textiles. One of the really nice things about Chiz is they're able to help you with your green initiatives or your sustainability initiatives. And there's 3 specific ways they can do that. They have rod over bent electric element modules, which are modules of ceramic fiber with heating elements kind of embedded in, which you can replace. You could replace burners, or you can replace your current electric heating elements with these high efficiency elements. So that's the first thing. They can also help you with a very simple one, and that is making sure your furnace door is well sealed. If you have a problem with your seal on your furnace door, Chiz Brothers is somebody you should call and talk to them about that. And also, they've got some of the newer products as far as ceramic blanket goes. It's a Dura Blanket LT, which are now available. So and these are excellent thermal conductivity, have excellent thermal conductivity properties. So feel free to give them a call on those 3 products, which could help you with your green initiatives. And finally, if you're doing induction, they have induction capability as well. They purchased a company called Advanced Material Science, which specializes in insulation for induction applications. So if you get a chance, give them a call or go on their website at www.chizbros.com, CHIZBROS.com. Check them out, and thank you to Chiz Brothers for sponsoring this episode. All right, let's see. You mentioned modules before, but I want to take a little bit of a different angle here. Talk about electric element modules.
Yeah.
The modules you were talking about have no type of heating element in them. There's just simply the insulating modules that you put on the side of the wall, side by side, maybe alternate the orientation. But what I want to talk about are these heating element modules. Can you describe what those are and why you're using them, and maybe hit on the decarbonization or electrification element of this?
Yeah. Traditional fiber modules, you're using those in a gas furnace, right? Even, an electric furnace that may be heated by glow bars or radiant tubes or something like that, and that's still going to have a similar penetration there. One of the systems, we call it our ELE system, that we have, gosh, I'd probably say in the last 2 years, we've probably had as many inquiries or at least conversations about going to these electrically heated modules than we have in past 5 to 10 years combined. A lot of that has to do with companies wanting to get away from gas, or they've got pressures from different environmental reasons or cost saving reasons. Name it. But yeah, so what we're doing with that is, we are actually hanging the elements on the ceramic fiber module. And, when they show the pictures of this one, there'll be one in there. But what that does is, it allows us to do a modular system where they can get a lot of power on those walls. And it lets us keep a lot of the same insulating value from using modules, but not having to use brick or something in the sidewalls to support some super, super heavy element. So, really what we go to there is, we can match, someone says, hey, we're putting this many BTUs of gas. Here's the load size, weight, all that. We can do the electric calculations to see how many kilowatts of power we got to pump into these furnace and elements in order to heat something up, just like, yeah. And, rest assured, someone a lot smarter than me does those calculations. So I'm just a pretty face that gets to sell them, right? Uh, um, yeah, so no, I mean it's something that we're seeing a lot of. I mean it's just a big push, obviously from the government, but boards of directors,
Right.
like,
Yeah, and
everyone's pushing.
it helps companies. It's going to help companies reduce their carbon footprint if that is their desire. Obviously, the I have a question for you about those, specifically about installation. Like, if every module needs a power source, do you have to like punch a hole in the furnace wall for every module, or can you interlink them and only have one power source at the end of the chain?
Yeah, so yeah, good question. I didn't do a good job describing that, but the modules will still go in just like a regular module. They actually have an extra set of ceramic tubes in them. So then as we do our design, we know where the elements are going to be hung. So yeah, I mean, if you've got a 10-foot wall, you're not going to have 10 1-foot pieces of element. You're going to have an 8-foot string of elements along that wall, and they will be hooked into the loops. One end of the hook will go on a loop, the other end will go on the ceramic tube that's inside the module, right? So yeah. On one wall, if you're gonna have a, let's say 12 by 12-foot high wall, right? And you may have a 10-foot element in there, you're probably only going to have 4 penetrations, maybe more on that wall, right? It's not going to look like Swiss cheese. They're going to be linked together. That goes by, like, these are all kind of like number of zones in a furnace too. I mean, that can all be, some super high aerospace applications where, they're going to have, everything's going to be super fine tuned, just like it is with burners, right? I mean, we think about certain applications you have to have way more precision and control over burners. Same thing can be for these elements too. And, the more precision and control you need, the more complicated it's going to be, just like it is with burners. But yeah, no, before you hang the elements, you could look in that furnace and it would look just the same as a regular gas fired furnace without the burners, right? Then you start, hooking the elements on the walls. And yeah, I think like when they have the pictures on this, that'll
Yeah, that'll clear
visually
it up. That'll clear it
bother
up.
me probably, but yeah.
Picture's worth 1,000 words, but there you go. So, when I think about ceramic fiber, thanks for the explanation on the modules, by the way. So let's go back onto ceramic fiber for just a second. When I think about ceramic fiber, one of the things I think about, you don't often see it in a furnace if the door's closed and whatnot, but a lot of times you'll see it jammed in around the doors,
Yeah.
you know, which to me doesn't look like that's the way it's supposed to be. So, I mean, I think doors are an issue, right? I mean, can ceramics help
Yeah.
on that or?
Yeah. So I mean, the heat treating furnaces, the temperatures aren't totally crazy. We're like forging furnaces where we're getting a lot of shrinkage. So they're replacing it all the time, right? Temperatures lower. So the main wear and tear item we see when we're repairing stuff or working on a repair with a customer would be around the doors, because they're just getting the mechanical abuse of constantly changing. And, some of the decarbonization, talks I've been in, and even talks I've given on at trade shows and stuff like that, we're really looking, when you're looking at ways to save heat, I mean, just making sure your door is sealed properly. It, I mean, it can go do wonders, right? I mean, if anyone has seen Home Alone, he goes in his basement, his furnace is shooting out all the flames. I mean, you walk into a plant, you can see that, right? And it's like, okay, you get that to seal right, like there's heat leaving that. And, so you go to a lot of these, you hear all these decarbonization talks, you see all these millions and millions of dollars being thrown around. And really you can make huge difference by simply on a shoestring budget by simply making sure your door is sealing the way it's supposed to seal. I mean, there is, I mean, if you can see the heat coming out, then if 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 that heat was dollars coming out, like one of those hurricane things where everyone's trying to grab the bills on a game show, think about that with dollars flying out of your furnace. You have people lined up who really be all over that, every day of the week, right? So you got to look that way. But I think, you hit the nail right on the head there. I mean, it's a really small, easy way to take a calculated decarbonization effort by making sure you have a door plan where you're changing it right. Same easy thing with tuning burners. I'm sure any of the burner guys who you talk to could not easily all the time, but little tunes to a burner can save tons of gas and tons of
Yeah.
CO2.
Yeah, yeah. I'm putting make sure you're maintaining good flame curtains on a continuous furnace. All that stuff just keeps the heat from coming out. Now,
Exactly.
did I look correctly or did I see correctly? You guys do door repairs, do you not?
Yeah, yeah. So we'll do door repairs in our own shop. So if someone ships a door to us, we'll do the relines there. Yeah, we don't have our outside. We don't have. Yeah, maybe 20 years ago, we stopped having our outside contracting arm. So yeah, we're not doing any of the field work there. But yeah, we do doors in our reline doors in our shop. Again, fiber is pretty easy to work with. So, you know, door perimeters are something that can easily be done by someone's own maintenance crew, right? Yeah, maybe they'll need one of our guys, sales guys there, kind of making sure they're doing it right for the first two times. But it's not typically it's not the hard thing to do. You got a 12-inch module perimeter, switch those 40 modules out once a year and you got a,
You got
fresh
a good
gas
seal.
safe.
Yeah, yeah. All right, let's shift gears just a little bit and talk about typical maintenance of ceramic insulated furnace. What do we need to be careful about? Any tips or tricks you can offer?
Yeah. So, the another really affordable thing to do is, and you can probably sometimes see this if you're going to have a hot spot where paint's chipping off or melting, but you got a temperature gun, you can find those hots. And if you see heat on the outside, then you're typically going to probably see some sort of crack or gap on the inside. So, really just, maybe making sure you have scheduled maintenance downtime where you're stuffing any of those cracks. Right. Right. Big thing. If you've got a really big furnace or a continuous furnace, roller hearth furnace type thing, you know, probably the roll seals are some of the areas where you're going to end up losing a lot of heat because, again, there's more wear and tear there. There's just more opportunity for expansion and contraction. So, keeping that there. We do have ceramic pumpable products. We call it almost liquid ceramic fiber that, if you've got a hot spot on a furnace and it's a big one and you can't get in there, you can drill a little hole on it, pump it in from the backside, fill that up. Yeah, yeah. I mean, you don't want to start again making your furnace Swiss cheese and poking holes ever. But uh, yeah, quick stopgap if you can't get inside the furnace, fill it in from the backside to because what you don't want to have happen is those hot spots can grow and cause problems, right? You don't want them to grow and get to the hardware, and you may have a module, the hardware gets too hot at the backside, module ends up falling in, right? That's worst case scenario, right? So if you can get out ahead of it by filling some of those gaps, that's a great way to go too. Refractory on the hearth too. I mean, if you don't want to replace a hearth, I mean, you can find a refractory contractor that can come in and, you know, spray over, if you have a big, big furnace, gunite some refractory over the hearth to fix any gaps or cracks or things like
That's
that,
more for
stuff.
castable though, you're talking about,
Yeah,
right?
yeah, cast
Okay.
gunite, yeah.
Okay. Yeah, yeah. Okay.
So on the fiber side of things, yeah, I mean, like most things, you're looking for hot spots.
Yeah. So
Really just
I guess the tip there is just make sure you're taking a regular thermal imaging of your shell of the furnace. And if you're noticing some hot spots, time to investigate.
I would have, if I would have had my prop. I know my prop handy here, but yeah, I mean, you can if you have a lot of furnaces and you can get a thermal imaging gun for a couple $100, you can really, I mean, get even bigger. You know, the doors. I mean, it'll blow your mind if you look at the temperatures on a fresh door seal versus you that door seal. I mean, even have a temperature gun to justify to your bosses, hey, we relined this and it was 150 degrees. This time last year, it was, 250, 350 degrees, right? So, I mean, you don't need, common sense can tell you, hey, we're losing more heat when it's
Yeah.
like that.
Yeah. Yeah, exactly. Okay, so let me ask you this. We're winding down here. I think I've just got two or three more questions for you.
Yeah, yeah, yeah.
So, can you address, if you don't mind, Mark, can you address the concern that some furnace users have regarding free floating fiber,
Ye-
especially in furnaces where there's high velocity airflow?
Yeah. So a couple things there. Yeah. I mean, we talking about the benefits of fiber versus brick and cast. Well, one of the benefits of the hard refractory is it does better with high velocities, right? So, Patriot furnaces may have a fan in there, typically they're not getting high enough where we got to worry. You can put coatings on the fiber, rigidizers, things like that to harden them up, make sure you're not have all that going. But from a health and safety perspective, yeah, I mean, and anytime you're working with fiber, you want to make sure you're wearing a mask, right? They have the warning labels on them. It's not like it was way back in the day, not allowed to say the A word, but, all the lawsuits
We'll
and all
put it
that.
on the screen. We'll put it on the screen.
Yeah, 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 yeah. But yeah, yeah, there's not worries like that too. But refractory ceramic fiber still does have a warning label on it. Now we do have body side soluble fiber, AES, alkaline earths, silica, non-RCF fiber, a lot of bunch of fancy names. More prevalent in Europe because of some of their rules. California's got a lot of rules with it too. But it's we do supply that as well. It doesn't have any sort of warning labels on it. Obviously, you're still working with it. You want to wear a mask and everything because dust in general isn't good. But it dissolves naturally with the body's. It's naturally soluble with body. So, does have some. It's not quite as strong. Can have more shrinkage at lower temperatures. But again, that's just talking with somebody, understanding what the right product is to use. Ranks can be a little worse, but yeah, I mean, there is a slight move in that direction, but it's not drastic, not
A
drastic.
slight move in which direction?
Going to the body soluble fibers,
Oh, yeah.
right? Because
Okay.
there is no warning labels on it. And some of the similar concerns where foundries have with sand and airborne silica, right? Technically, I guess going to the beach, we have airborne silica too. But so yeah, there's justification to taking those precautions. Certainly not all doom and gloom like
The
some
one
other.
that I heard was more of it wasn't so much a human safety issue. It was the use of these ceramic blankets inside of like an aluminum annealing furnace, where if the fibers got airborne, they would come to rest on the coils and would basically mess up the, especially if it's a strip going through, and you've got
Yeah.
contaminated coil now, or it's marked.
So the issue with that is the shot on the fibers. So the ceramic fiber is essentially little glass beads, right? Like a tadpole tail, like it's a tadpole head, and then there's a fiber tail that interlocks, right? Those little glass beads and fibers come a long way, right? So the shot content is way lower than it used to be. But yeah, I mean, it's certainly a concern. If that gets on a coil and then it goes through the rolling mill and you make a small dent, the glass. Yeah. So again, a lot of different things can be done with that too. People put up cladding, people rigidize it to lock the fiber in. uh, so yeah, I mean, there's definitely concerns for all the applications. Yeah, I mean, big aluminum homogenizing furnaces may have that. Traditional smaller batch annealing furnaces, not there. But I mean, it'd be the same thing if a little piece of brick chipped off or broke off onto, the worry with some of the fiber stuff is it's obviously a lot smaller, so you don't get
Yeah.
to.
And it's
Yeah,
a lot more conducive, and you can imagine the difference between a brick being hit with high pressure, high velocity, probably better to say, high velocity air, and a fiber, you would just see the degradation of the fiber. A fiber ceramic blanket would go down quicker, so that's good. You already hit on some of the safety things. I was gonna ask you about that, but it sounds like that you've hit on that pretty good. Um, I have one other question for you just about Chiz, if
yeah,
I
yeah,
could,
yeah.
and we can wrap up. which
Fire away.
it kind of surprised me a little bit because you were just to mention to people, Mark's company was one of our sponsors at our recent boot camp,
Oh
and
yeah.
I was surprised when we came by and saw that you had an induction coil on your table, and I'm going, okay, what's this all about? So, if you don't mind, just address what it is Chiz is doing in the induction area here.
Yeah. So we, company down the road from us, Advanced Material Science, we were using them to machine some of our fiber boards and bricks that were a little too complicated for what we had in house at the time, right? They had some really good CNC equipment up there.
Yeah.
And the guy who owned AMS, Advanced Material Science, was looking to sell off that branch of his business. And, we had been one of his bigger customers. So, or we worked with him, came to an agreement. And, so we bought the company, still out of the same building, same equipment, same guys that are doing all the good work. And so we kind of started getting in there and, saw a lot of the induction, I don't want to say furnace, induction coil, whatever
Yeah,
we're
the
saying.
heating equipment, induction heating
Actually,
equipment.
yeah, those heating equipment being on the customer list. And so, yeah, a lot of those electrical plastics, high temperature plastics, electrical Marinite translate boards, which, we got into a little bit in the Chiz Brothers world, but not like fully dove into it. Cause again, the temperatures are a little bit lower to what,
Yeah.
we're dealing with on the ceramic fiber side of things. So yeah, and it's been really good for us. They've got great machining capabilities down there to machine some of these complex parts out of Lima G10 and Marinite transit, all these terms that were relatively new to me when we bought them, right?
Right.
But it's really helped us at some of these trade shows because, three types of furnace guys walk by, gas-fired guy, he's my best friend, induction guy used to be like, there's not that much we can do with you.
Yeah.
Now we can do a lot with them. And then I'm still trying to figure out how I can be happy when the vacuum furnace
When the
guys,
vacuum-
that'll be a different battle for
Yeah.
a different, not trying to get into the graphite felt world.
Yeah.
So
Right.
probably
Right.
just take can't be friends with everybody sort
Yeah,
of
that's
thing on
right.
that.
Well,
But yeah, no, it's been good to kind of get into that industry. And, again, something that we've been, over the last year or two kind of growing just because we hadn't been nothing people quite as much as we had. Yeah.
no, that's good. Well, we'll look for opportunities for you to be friends with the vacuum people. One thing I know from experience, Mark, you could be friends with anybody, so it's okay.
Yeah.
I'm sure you can work it. I'm sure you can work
Trying
it.
my
So.
best. Trying my best.
Yeah, you're doing good. Hey, listen, that's great. Thanks so much. I appreciate your time.
Yeah.
Appreciate you being here.
Thank you, Doug. Thanks. Yeah. Look forward to seeing you at the next
Event.
trade. And I won't tell anyone watching, Heat Treat Boot Camp was great. Whether you're a
Appreciate that.
supplier, whether you're a heat treater, it's a good group of people, just bouncing ideas. Obviously, it's a crash course on 100 different things in 2 days. But I mean, I learned stuff. I was there to sell stuff, but I actually learned stuff too. So it was an added bonus. Yeah, no, I'd recommend anyone watching. It's a good way to force yourself to get out of the office to actually be locked in learning stuff, rather than, if you're doing it on a webinar or even this, but like, you can it's easy to find reasons not to listen when you've got a million other things going on, but in locked room for the boot camp was that was the first one I went to. And we'll definitely be back for any further ones.
No, I appreciate that. Now I owe you something. I'm sure. I'm not sure what it is, but we'll figure it
Oh
out.
yeah.
All right.
I knew what I was doing when I made that plug.
Yeah, I know. Put me in debt to you. All right. Well, let me wrap up here. Listen to everybody. Thanks for listening. I appreciate it. Hope you enjoyed listening to Mark Rhoa talk about ceramic fiber. If you want to get in touch with Mark, we'll either put his contact information up on the screen right now, or if you're just listening and not watching, you can get a hold of me and I can put you in touch with Mark. My email address is doug@heattreattoday.com. If you don't mind, give Heat Treat Radio a 5-star review or a like on anywhere you listen, basically any of your podcast apps, whether it's Spotify, Apple, SoundCloud, iHeart, Podbean, or wherever you listen. If you give us a good 5-star review, that will be helpful. It'll bump us up and maybe some other people will be able to listen. Also, though, if you're not listening on a podcast platform, you can listen right on Heat Treat Today website. It's www.heattreattoday.com/radio. You can find more episodes there. We have over 100 episodes out now. In fact, I think with this one is going to be 115, something like that. So let us know if you would like us to cover a special topic on Heat Treat Radio. Happy to do that. Always good to hear from listeners. You can send those suggestions to me at doug@heattreattoday.com. And don't forget that this and every other episode of Heat Treat Today or Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without any advance written permission, without getting advance written permission from Heat Treat Today. Again, I'm Doug Glenn, your host. Thanks for listening.